Hello guys, we are from Group 7. Today we present about the topic production of petrochemicals.
Assalamualaikum. My name is Nur Amira Balkis. Okay, for introduction, petrochemical derive from crude oil and natural gas, which are essential for producing plastic, synthetic fiber, fertilizer, and detergent. However, their production is highly energy intensive, contributing significantly to carbon emission and air pollution through processes like crude oil refining, transportation, and chemical cracking. This results in greenhouse gas emission, acid rain, non-biodegradable waste, and health issues, which is give an impact to such a respiratory disease and developmental problem in children. While petrochemicals are vital to modern industries, their environmental and health impact highlight the urgent need to sustainable alternative, energy efficient technologies, and stricter emission controls. Okay, next, as for objective, this project aims to explore air pollution, its sources, and its health impact on vulnerable groups like children and elderly. It is also highlight its environmental and economic consequences, including climate change, biodiversity loss, and financial burdens. The project evaluates current mitigation strategies such as renewable energy adoption and urban green planning, and also proposes sustainable solutions. It is also emphasizes the role of public awareness in driving behavioral change and the importance of international collaboration in addressing this global challenge. The project emphasizes the need for collective action to protect public health and environment.
Hi, Assalamualaikum. My name is Nur Atira binti Muhammad Hanafi. My metric number is CN220331. So today I would like to present about petrochemical productions. So petrochemical productions refers to industrial process of converting hydrocarbons. It's mainly from crude oil and natural gas into chemical products used in various industries. So common petrochemical products. First, plastics. It containing materials such as polyethylene, polypropylene, and PVC. Next is synthetic fibers. It contain material nylon and polyester. Third, fertilizers. It contain ammonia and urea. Fourth, solvent and detergents. It contain materials such as acetone and methanol. And the last one is rubber and resins. It's styrene, butadiene rubber, and epoxy resins. So for the source of air pollution in the petrochemical industry is the petrochemical sector contributes to significantly to air pollution through the extraction, production, and processing of hydrocarbons. Main causes of air pollution in this sector is first venting, second flares, third leaks from storage tank, and the last one is burning processes within production. So next is advanced technologies and device. So for the petrochemical industry has adopted advanced technologies and device for air quality improvements that will always specifically target pollutants and emissions reductions. So first is flare gas recovery, second is electrostatic precipitators, third is wet scrubbers, next is dry scrubbers, and the last one is leak detection and repair, which is LDAR.
Modern technology has an important role in fighting against the air pollution not only from petrochemical industry, but also the others. So we find out these technologies that can help, which is the wet scrubbers, activated carbon absorber, and the backhouse filter technologies. Okay, so now we will talk about each of their advantages, drawback, and also the sufficiencies. So for the wet scrubbers, advantages is it will provide versatilities and it will give a cooling effect to cool down the exhaust gases. So for drawback, one of it is the funding issues. It need more extra treatment and it will adding the expenses. So for its sufficiency, it will control larger particle but it less sufficient when contacting with very fine particulates. And for activated carbon absorbers, advantages is it also support the volatile organic compound emission standards. And in reusable carbon can help to reduce cost. It also compact and scalable. For drawback, it will need a high initial cost and maintenance cost, where sufficiency is not suitable for managing particulate matter gases, so it will need to combine with other technologies to work. And lastly is the backhouse filter. Advantages is very high efficiency and it also follow the particulate emission regulation strictly. For its drawback, yeah, its installation and the substantial expenses is very important. So and also the high energy consumption for the backhouse filter system. And lastly is the sufficiency. It's excellent. It's high efficiency, excellent for controlling many types of particulate matters.
Hi, good morning. Today, I briefly explain the standard governing emission in Malaysia, particularly for the petrochemical industry. These emissions are regulated under the Environmental Clean Air Regulation 2014, which are enforced by the Department of Environment under the Ministry of Environment and Water. The regulation sets strict limit on the pollutants such as sulfur dioxide, nitrogen oxide, carbon monoxide, particulate matter, volatile organic compound, ammonia, and other harmful substances. These measures are crucial to ensure industry operate responsibility while protecting the public health and environmental. Thank you. Hi, good morning. Today, I briefly explain the standard governing emission in Malaysia, particularly for the petrochemical industry. Good day everyone. Today I will be presenting about the best available techniques according to the appendix 2 that provided in the instructions. So volatile organic compounds VOCs pose significant environmental concerns in production of petrochemical and various control strategies have been developed for their management. Recovery and reuse technologies include adsorption, which employs porous materials to capture VOCs and can be regenerated for continued use. Condensation, which cools vapor to reclaim VOCs in liquid form with recovery rates of 50 to 98%. And absorption, where liquid solvents absorb VOCs before being inclinated. Destructive techniques such as thermal oxidation inclinate VOCs at high temperatures, achieving 95 to 99.9 efficiency, while catalytic oxidation uses catalysts to lower the reaction temperature. Biological treatment methods leverage microorganisms to decompose VOCs, especially effective at lower concentrations. To control VOC emissions from storage and transfer, strategies like external floating roof tanks can cut emission by 70 to 90%, and fixed roof tanks with internal floating covers can reduce emission by 70 to 85%. Implementing high quality equipment and leak detection and repair programs further minimize the fugitive emissions. For managing combustion gases such as nitrogen oxides and sulfur dioxide, techniques include using low nitrogen oxide burners, selective catalytic reduction, and switching to lower fuels to mitigate emissions. Additionally, particulate matter control can be achieved by using natural gas along with the bag filters and electrostatic precipitators. Emission monitoring through continuous tracking and stack sampling ensure compliance with environmental standards while regular LDAR checks help in earlier detection and repair of leaks from various sources. These measures collectively contribute to reducing the environmental impact of the petrochemical industry while adhering to the regulations. Now we are going to look into the comparison of
actual devices that used in the production of petrochemical industry. The first one is electrostatic precipitators, which have high initial cost but low operating cost, requiring regular maintenance while being efficient at capturing fine particles. They are commonly used in industries like power plants and cement factories. Backhouse filters, which have a moderate cost, offer high filtration efficiency but require regular maintenance of fabric bags. They are utilized in various sectors including cement manufacturing and power generation. Wet scrubbers are also moderately priced and effectively control gaseous emissions but produce wastewater that needs treatment. They are used in chemical manufacturing and power plants. Regenerative thermal oxidizers come with high initial cost and are high efficient at destroying volatile organic compounds with the ability to recover and reuse the heat, although they require regular maintenance primarily found in chemical manufacturing and paint production. Catalytic oxidizers, which operate at low temperature, also have high initial cost and require periodic catalyst replacement, being effective at destroying VOCs in chemical and petrochemical industries. Cyclone separators are characterized by their low cost and simple design, working well for large particles but being less effective for fine ones. They serve as pre-cleaners before other devices. Lastly, activated carbon absorbers are highly effective at removing VOCs and odors, but come with very high cost and require regular replacement or regeneration of activated carbon, commonly used in chemical manufacturing and wastewater treatment.
And lastly, after the research were conducted, these are the conclusions that we can conclude, which is the petrochemical sector contribute considerably to air pollution by emitting toxic compounds such as particulate matter and greenhouse gases. New pollution control technologies such as flare gas recovery system, selective catalytic reduction, activated carbon filter, and electrostatic precipitator has proven efficient in lowering emission. The use of BAT, which is best available techniques, has also enhanced the industry adherence to environmental rules. Addressing environmental concerns necessitated the regulatory monitoring and technological improvement, and also collaboration between government, corporation, and communities. A comprehensive approach combining modern technology, strong laws, and educated public engagement can result in a cleaner future.